Personal protective equipment, or PPE, is designed for a specific purpose: to safeguard your health during a hazardous material emergency. OSHA regulations require that PPE be worn whenever a responder faces potential exposure to hazardous chemicals. PPE includes a protective suit in combination with a self-contained breathing apparatus, or SCBA. Gloves, boots, headgear, and other accessory equipment form the remainder of the protective ensemble. Knowing how to inspect, don, and doff this equipment is essential for ensuring the full protection of any personnel who may be exposed to the hazard. Choosing the appropriate PPE for an emergency situation requires considerable knowledge and experience. A variety of suit designs and materials are available, offering a wide range of protection. Selection of the most suitable protective clothing can be complicated because there is no one type of material that protects against all hazards. Each emergency must be evaluated individually as to the exact type of hazard, the physical environment of the response, the duration of exposure, the availability of appropriate PPE, and facilities and supplies for PPE decontamination. All these factors will influence your decision in selecting the appropriate protective clothing. HAZMAT teams that aren't adequately equipped should not take an offensive role in the response.
That was 5 10-gallon cans.
An effective incident management system is the key to ensuring the safety of personnel involved with a hazardous materials emergency. As an essential part of the management system, the officer in charge is responsible for identifying the hazard and consulting different references to determine which types of clothing will offer the most effective protection. Chemical compatibility charts, such as these, provide a matrix of clothing material recommendations for a wide range of chemicals. Unfortunately, most are not product-specific. They include only generic recommendations that may not reflect the particular product you're using. The best information is to be found in clothing manufacturer guides that provide independent lab test results for their materials. But even these may be lacking sufficient information. It's also important to remember that lab conditions will be dramatically different from conditions found in the field. Most hazardous material emergencies involve mixtures of 2 or more substances. In addition, the presence of heat or open flames can produce a thermal reaction or hazardous products of combustion. Compatibility charts and manufacturer recommendations don't document performance in these situations. As a result, decisions for selecting appropriate protective clothing in these situations requires extensive training and research by the officer in charge. Such research must include information from the manufacturer as well as other outside sources. When hazardous chemicals come in contact with protective clothing, exposure may occur even though there are no visible indications. The integrity of PPE material can be breached in 3 ways. The most obvious of these is material degradation. Degradation occurs when a protective material loses its integrity after exposure to chemical or physical hazards. Degradation may be so slight it's almost invisible, although the results can be disastrous. Penetration refers to the movement of chemicals through openings such as zippers, seams, tears, or imperfections in the material. Permeation occurs when chemicals pass through protective clothing material on a molecular level as a gas. As a result, it's virtually impossible to detect permeation visually. The rate of permeation depends on the type of material, its thickness, and the concentration of the substance. Environmental factors such as temperature and the presence of heat and open flame also influence the rate of permeation. Most compatibility charts are based on material resistance to either permeation or degradation. However, selection must always be based on permeation data. If such data isn't available, a response should not be made. There are many types of personal protective suits. Each type is designed to provide a specific level of protection for the wearer. Fully encapsulating vapor protective suits are one-piece garments that enclose both the wearer and his or her SCBA. These suits are designed for gas-tight integrity and offer the highest level of skin protection against dusts, liquid splashes, vapors, and gases. NFPA Standard 1991 specifies performance requirements for vapor protective suits. This standard, as well as other standards mentioned later in this program, should be available through your command system. Although vapor protective suits provide the highest level of protection, they present certain disadvantages for the wearer. Because they're gas-tight, they don't allow body heat to escape. A buildup of body heat will cause heat stress. Also, these suits impair wearer mobility, vision, and communication. Vapor protective suits are not designed for use around open fires, heat, or flammable atmospheres. Although they may be used in combination with fire-resistant clothing, vapor protective suits alone provide no fire protection. A second type of protective suit is designed to resist penetration from liquids. Liquid splash protective suits are non-encapsulated, one or multi-piece garments. These suits are designed to provide liquid-tight integrity and to protect against splashes, dusts, and other particulate materials. NFPA Standard 1992 specifies performance requirements for liquid splash protective suits. Because they're non-encapsulating, however, these suits should not be used where repeated splashing or continuous contact with a liquid is expected. In addition, wearers of these suits may still experience heat stress. Like vapor protective clothing, splash protective suits have no heat or fire protection. This is graphically demonstrated by the following flash tests performed on both types of clothing. As these tests illustrate, you must be extremely cautious when using splash and vapor protective garments around potential or existing fire hazards. Support function protective garments are designed to provide limited liquid chemical splash protection against incidental chemical contact for personnel working outside the hot zone, such as in decontamination, remedial cleanup, and training. NFPA Standard 1993 lists performance requirements for this type of garment. Structural firefighting clothing is rarely used in hazmat responses. While this gear protects against heat, hot water, and some particulate material, it does not offer any protection against gases, vapors, or liquid splashes. As a result, structural firefighting clothing provides very little protection in hazmat incidents. In addition to the disadvantages of specific clothing or equipment, there is a drawback common to all PPE. Its wearing tends to create a false sense of security for the hazmat team member. When wearing any type of protective gear, never think you're immune to exposure. Selecting the appropriate PPE for the incident at hand and using it properly is essential to an effective operation. You should never assume that protective equipment will function with 100% effectiveness. The integrity of PPE can be affected by the number and length of exposures, the amount of wear, and storage conditions. Clothing can deteriorate, and respirators can become inoperable even in the best storage conditions, particularly if there are long periods of time between uses. An emergency response is not the time to discover problems with your PPE. When you're entering a hot zone, you want to be absolutely certain that your equipment is working properly. An effective inspection program will help detect unsafe equipment conditions before you don protective clothing and before you enter the hot zone. In other words, before you're at risk. Inspections should be performed on a regular, periodic basis, as well as immediately before the equipment is donned for a response. Regardless of your specific procedures, your inspection should always be methodical and thorough. On a vapor protective suit such as this one, for example, your procedures may begin with an inspection of the inside of the suit, working down from the head. Inspect the face piece first for large cracks or networks of fine cracks called crazing that might interfere with visibility. Vapor protective suits must be capable of protecting against vapors and gases. Consequently, any openings, regardless of size, are potential routes for contamination. At the head of the suit, check seams between the face shield and hood for rips, tears, or gaps, and check the exhalation valve for tightness. Moving down the length of the suit, visually check all the inside seams and zippers. If the clothing has been previously used, it should also be inspected for discoloration, swelling, or stiffness. Such signs are usually caused by chemical attack and may affect the integrity of the material. After thoroughly inspecting the inside of the suit, turn it so that the outside is facing out. Again, check from head to toe. Inspect the face shield and the seams around it, as well as all other exterior seams. Test any zippers to make sure they can be moved easily and fasten any closures, Velcro tabs in this case, to make sure they're working properly. If your suit has attached gloves and boots, pull them out full length and visually examine them. Glove and boot seams and interfaces with the body of the suit are especially subject to stress and wear and should be inspected closely. As important as a visual inspection is, the best way to ensure leak-free operation of a vapor protective suit is through inflation testing. To perform an inflation test on most vapor protective suits, replace the exhalation valve with a pressure gauge attached to an air source. Secure all zippers and other closures, and inflate the suit to a specified pressure. After pressurizing, observe whether the suit can maintain the inflation pressure over a given period of time. Suits with even small pinholes can't hold pressure for very long. Coating potential leak areas with a soapy water solution will help you locate punctures. Bubbling indicates escaping air. While you're testing the suit, check the exhalation valve, since these valves allow the safe release of exhaled gases and are essential for preventing overpressurization. Make sure the valve is clean and in good condition. Reinstall the valve properly after the inflation test. PPE inspections should always include a check of breathing apparatus in accordance with manufacturer's instructions. Check all hose connections and secure any that have worked loose. Your equipment may be designed differently. After checking hose connections, check all SCBA straps for signs of stiffness, deterioration, or distortion, all of which may hamper its effectiveness. Fasten and unfasten the waist buckle to make sure it's working properly, and check the harness points to make sure the tank is secure. Check any other equipment attached to the straps. A personal alarm safety system, or PASS unit, is being used with this SCBA system and is tested for proper operation. Inspect all gauges to make sure they're set according to the manufacturer's recommendations. Examine the SCBA facepiece for scratches or crazing, as well as the condition of the webbing. Look through the facepiece to ensure that your vision is good. On this SCBA equipment, the regulator must be connected to the facepiece before the unit can be tested. After you've connected the equipment for operation, turn the bottle on. Check the purge valve against the air pressure and check the reading on the gauges. Test that the facepiece has a good seal by inhaling and exhaling into the mask. Then turn the tank off and breathe the remaining air to test the low air alarm. As noted earlier, the specific inspections procedures you perform will depend on the design of your equipment. However, it's important to keep in mind that all PPE, from structural firefighting gear to vapor protective clothing, must be thoroughly inspected before you use it. Failure to do so will compromise your health and safety. Donning chemical protective equipment should be a routine that's practiced on a regular basis. Wearing a protective suit improperly can not only damage the clothing, it may also put you at risk of exposure. Donning PPE is a complicated procedure that should be performed using a comprehensive checklist. Thorough training and practice will further ensure that your safety is not compromised during a hazmat emergency. The donning and doffing procedures you're about to see are specific to this vapor protective suit used for training. Your own procedures may vary, depending on suit design and other equipment used in your protective ensemble. Before you don any PPE, your vital signs should be taken to make sure you're in condition to wear the appropriate clothing safely. A second team member always assists when PPE is donned and doffed. The buddy system is just as important when donning PPE as it is when entering the hot zone. The entry officer must always be present to supervise the donning procedures. Donning equipment alone is difficult to do and increases the possibility of equipment damage. More importantly, wearing PPE incorrectly can endanger your health and safety. Adjust the fit of any headgear before donning ensemble clothing and equipment. However, don't leave the headgear on. It should be donned later in the procedures. Before donning PPE, remove any jewelry, belts, or sharp objects that might puncture the protective clothing. Also, remember that glasses and contact lenses should not be worn when wearing PPE. Any vision correction should be built into a facepiece. Wear the proper cotton or non-flammable clothing under your PPE, inner coveralls, for example, or other clothing specified by your department. You should drink plenty of fluids to protect yourself from dehydration. Visually inspect all of your protective clothing and SCBA. Apply an anti-fog solution to the facepiece if it's recommended by the manufacturer. If all equipment appears to be in good condition, don the SCBA harness and tank. The facepiece of this unit will be donned later. Tank covers are used here to prevent damage to the protective clothing. Then, if your communication system is working properly, you can go ahead and suit up. Sitting, place your feet in the legs of the suit and position your feet. Many vapor protective suits, such as this one, have splash cuffs. Your chemical-resistant safety boots should be pulled under the splash cuffs, which are then turned down over the boots. The SCBA facepiece is donned next. Adjust the facepiece so that it's comfortable. Check for a secure fit. Test the seal of the facepiece according to the manufacturer's instructions. If the facepiece seal is tight, put on your inner gloves to provide an extra level of protection. Long gauntlet, surgical-type gloves are often used. After donning the gloves, stand and pull the suit up. Place your arms into the sleeves and gloves. Have assisting personnel pull the back of the garment up and over your SCBA. Make sure the suit is adjusted around your shoulders so that your movements aren't restricted. Add outer gloves for a third layer of hand protection. Wrap duct tape around the outer glove to keep the glove from slipping and around cuffs and boots as an extra measure of protection. Be sure to fold the tape over at the end so it will be easy to remove. Don your headgear and have assisting personnel raise the suit hood over your head, taking care not to disturb the seal of your facepiece. Fasten all openings except those needed for connecting breathing apparatus. Secure any belts and adjust the head, leg, and waistbands for comfort and mobility. Adjust the suit to allow for good visibility through both the suit facepiece and the SCBA mask. The regulator is the last piece to be attached on this SCBA equipment. Remember that yours may be designed differently. When air has been connected, you and assisting personnel should make sure the respiratory equipment is working well and you're breathing easily before closing up the suit entirely. Finally, have assisting personnel double-check all the closures. Once you've donned all ensemble clothing and equipment, re-evaluate the fit. If the suit is too small, your movements may be restricted, increasing the chance of tearing the suit material. If the PPE is too large, it'll be cumbersome and affect your dexterity. Also, loose material can be easily snagged. Don't enter the hot zone immediately after donning your PPE. Check your communication system first and allow yourself a period of time in which you and assisting personnel can monitor your comfort, condition, and equipment function.
Remove your gloves.
Also, never enter the hot zone unless an incident management system has been established, a decontamination area is fully set up, decon personnel are appropriately suited, and EMS is on the scene. These sectors are critical to your health and safety when you exit the hot zone. Once you enter the hazard area, continue to monitor yourself as well as your partner for evidence of heat stress and fatigue, and try to prevent damage to your PPE. For example, don't kneel while in protective clothing. Avoid working around sharp objects. And to prevent permeation, don't touch your outer gloves to your suit. Periodically check your clothing for evidence of chemical damage, closure failure, tears, and so forth. However, always keep in mind that chemical damage and exposure can occur even though there are no visible indications. If you believe that the integrity of your protective clothing has been breached, you and your partner should exit the hot zone immediately and undergo decontamination. Always dispose of damaged PPE. Don't attempt to repair it. Doffing chemical protective PPE requires assistance from suitably attired decontamination personnel under the supervision of the officer in charge. Since full decontamination can't always be visually confirmed, other personnel run a significant risk of exposure. Specific doffing procedures vary according to the type of PPE and SCBA you're wearing, as well as your department's SOPs. However, many of the following steps apply to doffing all types of vapor protective suits. After gross decontamination, begin doffing the ensemble by removing outer gloves and boots first. This may be done alone or with the assistance of decon personnel. The vapor protective clothing itself is only removed after a secondary decontamination and final rinse. The decon personnel assisting you must always wear SCBA and an appropriate level of protective clothing. Have decon personnel unfasten the suit, lift the hood over your head, and lay it on top of your SCBA tank to keep it out of the way. Remove your arms from the sleeves one at a time. When your arms are free, have a decon assistant lift the top of the suit up and away from the SCBA tank, avoiding contact with your body. Keep your hands inside the suit. The assistant's hands should remain outside. Both of you should avoid skin contact with the outside surface of the suit, even though it has undergone decontamination. If you're wearing internal gloves, leave them on at this point as an additional prevention measure. The suit should be laid out on a protected surface behind you. Step away from the garment and remove your SCBA following the correct doffing procedures. Once all of your equipment has been removed, take off your inner gloves and dispose of them. Avoid touching the outside of the gloves. At this point, you can remove your inner clothing and wash thoroughly. All PPE should undergo decontamination before it's removed. Entry teams should be strictly monitored so that there is always time for decontamination. Following the proper donning and doffing procedures is one of the most important factors in minimizing the probability of contamination. You protect not only yourself, but other personnel and the environment as well. As valuable as PPE is in protecting the health and safety of the HAZMAT team member, use of the equipment itself may pose other dangers. One of the disadvantages mentioned earlier was heat stress. Heat stress may range from a simple rash or cramp to more serious heat exhaustion and eventually life-threatening heat stroke. The severity of the heat stress depends to a large extent on the amount and type of PPE that's used and the existing environmental conditions. The human body continually exchanges heat with the ambient atmosphere to regulate its own temperature. Physical processes, such as respiration and perspiration, help defend the body's core temperature. However, these processes work only when the temperature of the surrounding air is lower than that of the skin. When the temperature of the air approaches or exceeds the temperature of the skin, the body can't release its heat. And when humidity reaches high levels, perspiration can't evaporate. As a result, body temperature rises. Consider how quickly this condition can occur with protective clothing that's impermeable to air and moisture. The air surrounding the body inside the suit is quickly heated and humidified by your own energy expenditure. The greater your exertion, the more heat and moisture you generate. Your body begins to dissipate heat less and less effectively. To prevent heat stress, certain physiological factors, heart rate, oral temperature, and body water loss, must be checked before donning PPE and periodically throughout the operation. If a team member's heart rate exceeds 110 beats per minute at the beginning of the rest period, he or she should receive further rest and medical attention. If a team member's oral temperature exceeds 100.6 degrees Fahrenheit, he or she should remove protective clothing and remain away from the hazard area. If a team member's body water loss exceeds 1.5% of total body weight, he or she is dehydrated and should not continue to wear protective clothing. To help monitor these physiological factors, always use the buddy system. Never enter the hot zone without a partner. The advantages of using personal protective equipment far outweigh the disadvantages. The key to protecting your own health and safety lies in a sound knowledge of your equipment, knowing what PPE to wear and why, how to don and doff it, and when to recognize the signs of your own limitations.